Have you ever wondered why even the best athletes hurt after a workout? Well, you're about to learn why.
There are two ways the body produces ATP from sugar. The first, which is used the largest majority of the time, is called aerobic respiration. This metabolic pathway requires oxygen to break down glucose and generate energy. Common exercises that utilize this pathway include jogging, distance swimming, and hiking. The second pathway is called fermentation, which is used only when oxygen cannot be delivered quickly enough to perform aerobic respiration. This pathway is utilized during high-demand uses such as sprinting, lifting weights, or climbing. Fermentation allows the body to produce energy without oxygen, but that comes at a cost. The compounds that usually assist in aerobic respiration, like pyruvate, get converted into a substance called lactate. It's actually a common misconception that your body produces lactic acid, but in reality it is lactate that doctors refer to when they're talking about this substance. Production of lactate results in a pH drop in the muscle cells, which reduces the power capability of the muscles. Lactate and all the other metabolites that are produced during exercise cause the burning sensation you feel whenever you're doing these high-intensity workouts. While lactate and lactic acid might not be the same thing, they're very similar chemically. And while these compounds may make working out painful, lactic acid is actually very important in a number of different processes.
You might be thinking at this point, well, this is really nifty and all, but how the heck could a chemical that makes me dread working out possibly have any practical application whatsoever? Well, it turns out that unless you skipped breakfast today, the odds are extraordinarily good that you have used lactic acid today. So generally, due to the fact that lactic acid is a product of our bodies, it has extensive applications because it's a safe acid that our bodies know how to handle. So there are four categories generally in which lactic acid is useful in industry. Among these are food and beverages at about 35% of total use, polymers at 39%, and personal care at 13%, and solvents and other industrial uses. Lactic acid becomes lactate ion when in aqueous solution. It is this chemical, lactate, that comes in handy for virtually any food product connected to fermentation or the need of preservation. Most foods that contain lactic acid have a sour taste. Good examples of these include sourdough, yogurt, and sour beers. Most importantly, however, lactic acid is an important preservative and is a decontaminating agent in meats. Lactate also has pharmaceutical application. It is vital for the application of some life-saving drugs. It is used to turn drugs that are normally insoluble into water-soluble lactates. It also has cosmetic application. Due to its acidic nature, it is used to adjust acidity, act as a disinfectant, and as a keratolytic, thus is put in lotion and is used to remove warts, dissolving dead skin and keratin on the skin. One particularly interesting use of lactic acid is that it is used to remove ink from official papers and is a forging technique. During the time of World War II, this technique saved thousands of people's lives because they had the legal papers they needed to not be deported. It's pretty cool that lactic acid, a chemical produced as a byproduct of working out, can be used for so many things. But we don't take the stuff from our bodies. The industrial production of lactic acid is fascinating.
Lactic acid began to be produced on an industrial level in the 1960s when the need for heat-stable lactic acid in the baking industry arose. Lactic acid can be produced by two pathways, microbial fermentation or chemical synthesis. Chemical synthesis begins with the usage of petrochemicals, or substances that have been obtained through petroleum refining or natural gas. Acetaldehyde fits under this umbrella. HCN and a catalyst are added to the acetaldehyde and react to form lactonitrile, this compound you see here, CH3CHOHCN, which undergoes hydrolysis to reach the final product, D-lactic acid. In microbial fermentation, renewable resources are used and undergo pretreatment that involves either acid hydrolysis or enzymatic saccharification, a process that breaks complex carbohydrates into monosaccharides. Pretreatment aids in making further chemical reactions much more attainable, since the reactants are slightly simplified. These fermentable carbohydrates result in a fermented broth created by solid-state fermentation. Solid-state fermentation is a type of fermentation that involves using solids in the absence of free water. Afterwards, this broth undergoes a recovery and purification process to recover optically pure L+ or D- lactic acid. There exist two optical isomers, as mentioned before, L+ or D-, and each of them rotates light in a different direction. L+ rotates light clockwise, while D- rotates light counterclockwise. The two compounds are stereoisomers, well, rather, enantiomers of one another. There are many microorganisms that produce lactic acid, and these include bacteria and fungi. In another fashion of fungal fermentation, lactic acid is grown on a simple medium requiring vigorous aeration, which typically uses R-rhizase, which has a millilithic enzyme activity, which means that it's allowed to convert starch directly to L+ lactic acid. This is an advantage to fungal fermentation because we're able to produce lactic acid directly from a reactant. However, there is a mass transfer limitation using this process. When lactic acid is grown in a small medium, there's low product yield, and many byproducts are also created, such as fumaric acid or ethanol. Lactic acid can be produced from things like whole wheat flour, vine trimming wastings, lactose, and concentrated cheese whey. It's also used in the production of beer. Most frequently used methods of producing lactic acid are batch, fed batch, repeated batch, or continuous fermentation processes. Higher lactic acid concentrations are typically found in batch and fed batch processes because they're continuous. And cell recycle stream also allows for a higher cell concentration and product productivity.
Thank you for learning about lactic acid with us today. Join us next week for an exploration on stress hormones and their effect on the human body. Go Rams!